Okay, good evening, everyone. I hope you are all well. Thank you very much for your time. Okay, the last time or in the last video, we spoke about sex determination in human beings, wherein we were determining the percentage chance of the child born being a boy or a girl. So I hope all of you understood the sex determination in humans or in human beings. So today we are going to learn about the genetic diseases caused by sex-linked alleles in human beings, or we are going to learn about the inheritance of the sex-linked characteristics or diseases in humans. Now, the sex-linked alleles refers to what? To those diseases or to those characteristics that are transferred through the genosomes or the sex chromosomes. So today you are going to learn about the diseases that are caused by sex-linked alleles. Now, we have two types of the sex-linked diseases that are caused by these genosomes. The first one is known or is called color blindness. The first one here is color blindness. Now, what is color blindness? By definition, color blindness refers to the reduced ability of human to distinguish between what? Certain colors. It means that if you have a reduced ability to differentiate between different colors, we will say that you are suffering from or you have this disease in your mini color blindness. Now, the color blindness does not affect the vision of a human being, but it affects the ability of the individual to differentiate between different or certain colors. Are we together? Now, these diseases, it affects mostly males. Now, the color blindness is common mostly in males. Why? Why is this disease common mostly in males? It is common in males simply because it is a what? A recessive alleles. Remember, during sex determination, we learned that males have X and Y chromosomes, whilst females have got what? X and X chromosomes. Now, the allele for color blindness is recessive and it is only found in the X chromosome. It means that it is very rare to find a female who suffers from what? Color blindness. I'm not saying that they are not affected, but it is very rare. And this condition is commonly or is mostly found in males simply because males possess this or they contain X and Y chromosomes. And the allele for color blindness is found in X. And X is a what? Is a recessive allele. Here they are saying that I've already said that this allele is in a recessive condition. That's why it affects what? Mostly males. Now, what are the symptoms of this color blindness? Color blindness, one of the symptoms is that you will have a reduced ability to do what? To distinguish or to differentiate between different colors. You will have a reduced ability to differentiate between different colors. Zwamba zori mutu ane avako safara color blindness hanga koni uamba uri uyu muvara ndi ufio rikufana na msiapo zvino. Ende futi hei color blindness ndi condition inei riiwanesa ka vhathu va vanna zwoitwa nga mini? Zwoitwa nga uri hange ini ka sex determination ro guda uri dzi genotypes dza mufumakadzi dziva dzi X and X, then richiya kha dzi genotypes dza muthu wa munna yava X and Y. Hey, color blindness, hopefully it occurs in a recessive form and it is only found within the what? The X chromosome. Araranga check up between the female and the male. ne? Hoyo wa male wa female una X and X chromosome and hey condition ya color blindness hofi recessive and futhi riwana kamini ka X chromosome. Zwiamba zwori zwitova obvious uri hey color blindness I affect se vhathu va vanna nga uri muthu wa munna una X and Y chromosome and hey condition ya color blindness it occurs in a recessive form, therefore zwi possible uri muthu wa mufumakadzi a transmite hey allele ya color blindness kha ṅwana ane a khou ḓo begwa. A zwone kani ndi zwone kha ri humele ngeno murahu. Okay, before that tshiṅwe ndi tsha uri a female act as a what, as a carrier. She carries what, the allele for color blindness. That's why it is very rare to find a female who's suffering from what? From color blindness. Why? Because the female is a carrier of the allele for color blindness. That's why color blindness affect mostly what? Males. Are we together? Now, we are now going to look at an example here. We have got an example here wherein they are saying that if a normal female who is a carrier for color blindness, listen to this. A normal female who is a carrier for color blindness marries a normal male. What are the possibilities of their first child being color blindness? Here the question requires you to give the possibilities, the chances or the probability of the child being color blind. Ne? Now we are going to write down the key points of this question. They are saying that a normal female, key point number 1. Number 2, a normal female marries what? She marries a normal male. A normal male, ne? What are the possibilities of their child being colorblind? Ne? The possibility of the child being colorblind. Now, the question goes on and said, let X to the power B represent a normal chromosomes and X to the power small letter b represent a chromosomes with the gene for color blindness. Now, we are given a clue here. Here they are saying that the normal chromosome are represented by what? By X to the power B, ne? Then the chromosomes for color blindness are now represented by what? By X to the power small letter. Now, what are we going to do here? Here we are going to say, we'll write P1. In P1 we'll have what? The phenotype and the genotype. Ne? What is the phenotype? Remember, we said that phenotype refers to what? It refers to the physical appearance. The physical appearance here, we are having what? We are having a normal female who married what? X. She married a what? A normal male. Now we are moving on to the what? To the genotypes. What are the genotype? We are referring to the genetic makeup of an individual. What are the genotype for the female? We already know that the genotype for female are represented by what? By two X's, ne? Two X's are being crossed with what? With a male. Male are represented by what? By X and a Y, ne? Now, here they gave us a hint that we must use X to the power capital letter B to represent the genotype for the normal female. Now, here we are going to do this. And they also said that, let's go back to the question. The question says, let X to the power B represent a normal chromosome and X to the power B represent what? A chromosome with the gene for color blindness. Ne? Now, it means that here we must write x to the power capital letter B and x to the capital letter what? Small letter b. Ndingani rongwala x to the power b kurwane na x to the power b thuku. The reason is that ange ka question bori pa hint bari we must let x to the power capital letter b to represent the normal female, and small x to the power small letter b represent what? The chromosome with what? With a haemophilia, ne? I mean with a color blindness. Ne? Now we already know, or I've already alluded that the allele for color blindness is what? Is recessive. What is recessive? Or what is the difference between recessive and dominant? It means that it will not mask or it will not influence the physical appearance of the individual. It is masked by what? By the dominant allele. Ne? Shamba zoringori happen the small letter the x to the power capital letter b and x to the power b thuku. Shamba zori hoi female iba inormal ngori already b ya capital letter is dominant over what? B ya small letter. Shamba zori this female is what? The female is normal. Now what about the male? They said that we are crossing what? A normal male and a normal female. Already obviously here we're going to have what? X to the power what? To the power capital letter what? B, because we are crossing normal male and a normal female. Now, from there, what will happen? We all know that meiosis will occur to produce what? To produce gametes. Meiosis is occurring to produce gametes. Now, what are the gametes? Our gametes here, we're going to have x to the power b, x to the power small letter b, x to the power b, and y. Remember, I said that you must use the commas here to show that meiosis has occurred. Why meiosis must occur? It must occur to produce what? Gametes. What are the gametes? The gametes are the sex cells. Now, from there, the next step, what are we going to do? Now here, fertilization is going to do what? To occur. Fertilization is occurring. And what will happen? We are now going to use the Punnett square to cross these two individuals. We are now going to draw a Punnett square like this one. We are now going to draw a Punnett square like this one. And here, on this column, you must write the female and on this you must write the male. Now these two are going to cross, or they are going to do what? To mate. Now we have x and x, it will give us x to the power b, x to the power b. Then in this column we will have what? X and y, we will have what? X to the power b and y. When it comes to this one, we are going to have x and x, it is x to the power b and x to the power small letter b. When it comes to this one, we have what? X to the power small letter b and y. Now, after that, the next step, what are we going to write? We will write F1. F1 for what? For the first fluvial generation. After that, we'll write the genotypes and the phenotypes. Phenotypes. What are the genotypes? I said that the genotypes are the genetic makeup of an individual. Ne? It means that here we are going to write the results that we got from the Punnett square. We'll just come here and copy everything that we have. We will have x to the power b, x to the power b, and x, b, y, and x to the power b, x to the power b, and x to the power small letter b and y. These are our genotypes. Ne? Now, here we are moving on to the phenotype. We are going to identify the phenotype from the genotypes that we got during fertilization. Now, when you look here, we have one is a female who is what? Normal. Why? Because the B represents what? A normal female. Here we have a male who is normal. Why? Because B represents what? A normal male. Here we have a female who is normal. Why normal? She is normal because B is dominant over what? Over small letter b. And here we have X, the power small letter b, and Y, which is a male with what? With color blindness. Ne? Why is he suffering from color blindness? Because this one, it represents the allele for color blindness. Therefore, already this male is what? Is suffering from color blindness, because in his genotype, we have got X and Y to the power small letter b and Y to show that this allele is what? Is for color blindness and is recessive, and this one is what? Is dominant. Meaning that here we are going to write what? How many females we have? We have 3 normal females. 3 normal females, and what else? We also have 1 male with what? With color blindness. You see? Very simple, isn't it? That's all about color blindness. Now, you can also determine the percentage using the results that you got during the first fluvial generation. You can also determine what? The percentage. Arali mbuso yanga ya panda ya ripeni percentage ya uri mwana ondo bebiwa udoba ana Haemophilia kana anormal na. Percentage ya uri mwana abebiwe ana Haemophilia hapa. Rawana uri ndi 1/4. So now 1/4 times 100 guy is 25%. So the percentage chance of a child being born with Haemophilia here is what? Is 25%. That's all about a color blindness. In the next video, we will be learning about Haemophilia. Thank you very much.